Today we will study about the important topics of the organic chemistry for class 11th. And first of all, we'll start with the IUPAC, that is International Union of Pure and Applied Chemistry. First, we'll do the basic example, then we'll move forward. First example will say that is CH3, CH2, 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 CH double bond CH2. So in this particular compound, we have 6 carbons, and along with the 6 carbon, we have one double bond on the first position. So we'll do the numbering from the right hand side. That will be 1, 2, 3, 4, 5, 6. So since we have 6 carbon in the chain, so it will be hex and the first position, and just because of double bond, we have ene. So hex 1 ene. Some sort of this example can be come in your exams. Okay. Second, we can make like CH3, CH3, double bond, CH, single bond, CH3. Since in this particular position, the side chain is there, so we'll do the numbering from the left hand side. 1, 2, 3, 4. On the second position, double bond is also present. On the second position, methyl group is also present. So it will be 2 methyl and 4 carbon, that is but. Second position, double bond 2 and then ene. 2 methyl but 2 ene. More example, we can take like CH2 double bond CH single bond CH double bond CH2. Here 2 double bond are present, so we need to mention the position of both double bond. 4 carbons are there, then but, then 1, 3, just because 1, 2, 3, 4. On the third position we have double bond, the but 1, 3 diene. Next example we can take like CH2 double bond CH3 single bond CH3. So on the second position you can see we have a methyl group, and on the first position we have double bond. So it will be 1, 2, 3. It will be 2 methyl prop for 3 carbon, then 1 and then ene. Next, let's discuss more example, that is CH3 whole thrice CH2 CH3 whole thrice. In such cases, you can open the structure directly, you can count. I'm writing the name, that is 2, 2, 4, 4. Tetra methyl, and main chain we have 5 carbon, that is pentane. So it will be like this. Next example we can take like CH3 CH2 CH single bond CH2 single bond CH3 CH over CH3 single bond CH2 single bond CH3. So now how you'll do the numbering? You'll do the numbering from the side where the side chain is nearer, and you have to name according to the alphabetic order. So from the right side, if I'll do the numbering, it will be 1, 2, 3, 4, 5 and 6. On the fourth position we have ethyl group, on the third position we have methyl group. So it will be, how you'll either name that from the, you have to mention the position, but one rule is there, that minimum set of locant. So for that sake, you have to see the number of carbon on this side chain. So from the left hand side, if I'll do, ethyl group is having the more number of carbon, so I'll do the numbering from the left hand side. That will 1, 2, 3, 4, 5 and 6. That pink one will be the correct one. So if I write the name, it will be 3 ethyl. Okay, then 5, 1, 2, 3, 4, 3, 4 methyl, and then 6 carbon is there, then hexane. Okay, then sometimes the question can be asked like having the bond line notation, so it will be like this. So we have to count the number of carbon and the position of the functional group. So 1, 2, 3, 4, 5. On the third position we have ketone, so it will be 3, 5 carbon are there, then pent a no 3 pentanone will be the name of this particular compound. And we can make more structure like this, double bond O. So we have to count the number of carbon again, 1, 2, 3, 4, 5 carbon are there, then we use pentane. And just because of the presence of the double bond O, that is ketonic group, that pent 2-one, or you can write like 2-pentanone. It will be correct. Both are correct. Any manner you can write. Let's discuss more type of example like CH3, CH2, C double bond, O single bond, CH3. Instead of the bond line, we are having the carbon chains. So 4 carbon are there. 1, 2, 3, 4. Second position we have ketonic group. So it will be but-2-one. One more example, last example I'm taking of IUP, that is CH3C, CH3CH single bond CH, above it CH3 we have CHO, aldehyde group is present. So you have to name from the side from where the functional group is nearer. From the right hand side the functional group is present, so I'll write the name from that side. So 1, 2, 3, 4. On the second and the third position we have methyl group, so it will be 2,3 dimethyl. D will be capital, the first letter, dimethyl. 4 carbon is there, then butanol, just because aldehyde group is present. So these are the some examples which can be easily done by the help of basic IUPAC. Okay. Sometimes the question can be asked on the basis of hybridization. And I've told you the trick regarding this, that if the single bond is present, the hybridization will be sp3. If the double bond is present, the hybridization will be sp2. If the triple bond is present, then hybridization will be sp. And if carbon is from the left hand side and the right hand side, both sides the carbon is present, so it will be the hybridization again sp. So this is a simple trick you can use for the examination point of view. For example, I'm having some like CH3 single bond CH3. So we have 2 carbon here. Every carbon is singly bonded with the hydrogen atom and singly bonded with the carbon atom. So it will be this carbon again sp3 hybridized, this carbon again sp3 hybridized. Second example I can take like CH3 CH2 single bond CH3. Again this will be single bond to sp3, it will be sp3, it will be sp3. All are single bonded compound. If I'll talk about like CH3 single bond CH double bond CH2. So we have one double bond here. So this carbon will have sp3 just because this carbon is bonded with all the single bonds. But in the middle carbon, it is bonded with a double bond. So this carbon is sp2 hybridized. This carbon is again sp2 hybridized. So on the basis of the functional group, the question is asked. So we can do like CH3 C double bond O single bond H. So you have to see whether the compound is having a double bond or triple bond. So the carbon here is bonded with a double bond O. So first carbon will be the sp3 hybridized, second carbon will be sp2 just because of the presence of double bond. Same example like CH3 C triple bond C single bond CH3. So this carbon again sp3 hybridized, this carbon is sp, this carbon is again sp, this carbon is again sp3. So just see how many bonds are bonded with the on the left, right, above, down on the carbon side, or the 4 valencies are bonded with single bond, then sp3, double bond is present, then we have to go for the sp2 and sp3. Okay. So this is the basic things. Functional group is again a most important topic of this chapter. And so not functional group only, the functional group isomers are also important, chain isomers are also important, positional isomers are also important. So first I'll go for the isomers. What are isomers? Isomers are those compounds which have the same molecular formula but different arrangement of the atom. So main 3 to 4 type I'll discuss. That is first type I'm taking as chain isomerism. So in the chain isomerism, the number of carbon on chain is different while the formula is same, while the molecular formula will be same. For example, CH3, CH2, 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 CH3. We have 5 carbon over here. If the straight chain is there, it will be N-pentane. Okay. If CH3, CH over here, CH3, CH2, CH3. Number of carbon is again 5. Number of hydrogen is again same. But one of the carbon is on the side chain, not in the main chain. So it is known as iso condition, isopentane. On the same carbon, if I put more carbon on that side, that will be CH3C. CH3, above it CH3, and right side it will be CH3. So all the carbon valencies are occupied by the CH3. Now this condition is known as neo. So it is known as neopentane. So this is only about the chain isomerism. Let's discuss the second type, which is most important, that is positional isomerism. Positional isomerism is basically when the position of the double bond, triple bond, or the functional group is different. Then that type is called positional isomerism. So basically, short form we can write like position of double bond, triple bond, and functional group is different, and molecular formula will be same. For example, we can have like CH3, CH2, single bond CH, over it we have OH, here we have CH3. So on the second position where there is a functional group OH, while if I make the same example CH3, CH2, 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 OH, now here it will be known as 1-butanol, and here it is known as 2-butanol. What is the difference? This is difference only about the position of the OH. One more example we can take like of double bond like CH3, CH, double bond CH, single bond CH3. Okay, and one more isomer of this particular compound, it will be CH3, CH2, CH, double bond CH2. This is called but2-ene. This is called but1-ene. It means the only the position of the double bond is changed. That's why it is called positional isomers. Third thing for remembering, you can say like functional group. That is again a most important topic. In exam point of view, you can get the question from this area. For the functional group isomers, when the molecular formula is same, but functional group is different. Functional group is different. So this is called positional isomers. For example, I'm taking like CH3, CH2, CHO. This is called propanol, just because the aldehyde group is present. Same CH3, C double bond O, single bond CH3. Number of carbon is same, number of hydrogen is same, and one oxygen is present in the both of the compound. But if you see the left hand side, the propanol, just because aldehyde group is present, while on the right hand side we have ketonic group. This is called propanone, 2-propanone. Okay, so this is called functional group. The molecular formula is same. Last type, that is geometrical isomerism. Sometimes the question can ask from this area, in which you have to only remember the position on the either side of the double bond. If like C double bond C, A and B, or you can add a simple example in place of that, like we have here CH3, here we have CH3, here we have H, here we have H. Second example, C double bond C, CH3, CH3, H and H. So if the both the same type of atoms are not adjacent to each other, that particular form is called trans form. And if they are adjacent to each other, they are called cis form. So in geometrical isomers, same group, same side, cis, diagonally, trans. That's it. You have to remember only this portion. So this is all about the functional group isomers and all the isomers. Let's talk about the main thing. On the basis of the reaction, the question can be asked. And basically, in the past years, the question are like this only. So let's discuss about alkane. So alkane, first preparation method, which is that is from ethyl alcohol, and sometimes it is mentioned as ethanol. Okay, so ethanol, that is called dehydration reaction. Dehydration. So it will be like CH3, CH2, OH in the presence of concentrated H2SO4. Here H2SO4 is acting like the dehydrating agent. So what will happen? The water molecule will get eliminated out, and it will be CH2 double bond CH2. Okay, this is a this is alkene. We are talking about alkene. preparation of alkene. So double bond is present, so alkene is present. Second basic method of preparation of this alkene we use by dehydrohalogenation. By the name, this question is asked, like, what do you understand by the dehydrohalogenation reaction? So in that particular case, you have to just remember that you are using alcoholic KOH for eliminating out the water molecule as well as the KCl molecule. So see, like I'm taking example CS3, CH2, Cl. And when it react with the alcoholic KOH, this K will take Cl and gives out KCl, and one of the OH will take water molecule and it forms CH2 double bond CH2. So the formation of ethene is quite important in this case. Next, let's talk about some of its properties of alkene, that is ethene we are using there as an example. First is when it react with the cold alkaline KMnO4. This question is quite most important. Most of the time this question is asked. What happened when ethene react? Question can be asked like, what happened when ethene react with uh, alkaline cold KMnO4? What will happen? What will form? So this is quite important. Like CH2 double bond CH2, when it react with the water and it get oxidized in the presence of cold alkaline KMnO4, it forms CH2, both carbon will get the OH. This is called ethylene glycol. This is quite important. This is called Bayer's test. Why? Just because in this particular method, the color of this alkaline KMnO4 decolorize. So this is also a test for the unsaturation. If the question is asked like for the test of unsaturation, what you can use cold alkaline KMnO4. Second method for the checking whether the compound is unsaturated or not, we can take the help of bromine. So from bromine, what happen when it react? See, CH2 double bond CH2, when it react with the bromine in the presence of solvent CCl4, what it forms, both it will undergo addition reaction, one bromine to each carbon. So it will be CH2 single bond CH2 along with Br and Br. This is called 1,2 dibromoethane. See the reddish brown color of bromine here, the changes, disappear, decolorize, you can say. So this is also a test for this what unsaturation. Third properties, which is most important, that is reaction with ozone. Reaction with ozone. So CH2 double bond CH2, when it react with the O3 molecule, that is ozone, it forms CH2 CH2 OO. It forms, this is structure is called ozonoid. Okay, under the presence of zinc, it will undergo reductive cleavage. It will undergo reductive cleavage in such a way like this bond will break like this. And zinc will take on the oxygen, this middle oxygen, it gives out zinc oxide. Along with it, it forms CH2O, 2 molecule. So you can write like 2 molecule of HCHO, which is known as formaldehyde molecule. This is again most important in the ethene. Okay, so next let's talk about alkane preparation. Basically, most important question is how you prepare the alkane. Preparation question is quite common in the case of alkanes. So we are taking an example of first method of preparation from soda lime, by the help of soda lime. You can say by the help of soda lime or from soda lime. Okay, so we are taking C2H5COO Na, sodium salt of propanoic acid. Okay, so when it react with NaOH in the presence of calcium oxide, the mixture of CaO and NaOH, that is called soda lime, when I heat this particular solution, what will happen? This NaOH along with this particular portion gives out the Na2CO3, sodium carbonate. Along with this, hydrogen will come at this particular carbon and form C2H6. This is called ethane. So this is the preparation method. Okay. Second, we can use Kolbe electrolysis. You don't need to remember the anode cathode reaction, just remember the main reaction. So CS3COOK, CS3COOK, we are using the potassium salt. When it reacts with the water molecule, I'm writing HOH in case of water. What will happen? This K will take on one OH, this K will take on one OH. It will forms KOH2 molecule. Along with this, both the CO2 molecule will get eliminate out in the presence in the will get eliminate out. Along with what is remaining portion, that is CS3, it will combine and it is again ethane. So this is quite important. This is again most important. Third method we'll use, that is Wood's reaction. So Wood's reaction, the basic is Rx plus 2Na plus XR in the presence of dry ether. It will give out, see, one Na will take one NX, one Na will take one X. So it will give out two molecule of NaX along with R single bond R, that is called alkane. Let's take an example like CS3Br, bromoethane along with another molecule of bromoethane. When it react in the presence of dry ether, what it will form, Na will react with Br, Na will react with the Br, gives out two molecule of NaBr, and both of the CS3, remaining CS3, they will combine each other and form CS3 single bond CH, that is called again ethane. So this is quite important as for the exam point of view. Okay, let's discuss about the next topic, which is most important, that is about the alkyne. Okay, alkyne. So preparation method of alkyne is also important. First question is like how can you prepare ethyne by the calcium carbide? So it's very easy. Directly you can say you have to take the calcium carbide and pour some water in it. That is easy. Okay, two molecule of water I'm taking, it will form. Ca will take on, okay, I can see CaC2 plus two molecule of water. See, one Ca will take one OH, okay, and second OH also it forms CaOH whole twice, that is calcium hydroxide. Remaining carbon molecule along with these two hydrogen forms CH triple bond CH. This is easy method from calcium carbide. Second important method is from iodoform, that is CHI3. When react with this silver, two molecule of this CHI3 when react with the silver, one Ag will take one I. So we have 3I on the right side, 3I on the left side, and 6 Ag in the mid. So we can get 6 AgI molecule. CH is remaining, so it will be CH triple bond CH. So this is easy. Okay. What happens sometimes, the question can be asked like in a way in which you have to tell about the unsaturation. So for the unsaturation sake of thing, you can easily use the same thing like Bayer's test and bromine test. Same for the unsaturation over here. Okay, the color will decolorize. Next thing, properties of alkyne is also important. Only two properties. Generally, they are asked random, like frequently they can be asked in the exams. So what happened when the ethyne, react with hydrogen in the presence of nickel? So what will happen, like CH triple bond CH, this is ethyne. When it react with the H2 molecule in the presence of nickel, one hydrogen will get one carbon and to another carbon. So it will be CH2 double bond CH2. Again, when it react with the hydrogen in the presence of nickel, one hydrogen to this carbon, one hydrogen to this carbon, it will be CH3 single bond CH3, that is called ethane. And this is ethene. Okay, so we can say it will reduce to the ethene and then again bit further reduce to the ethane. Second time, if the question asks like ethine when react with water instead of hydrogen, then CH with water I'm writing here. CH triple bond CH, this is ethine. When it react with the water molecule in the presence of concentrated H2SO4 here, so it will form, see, hydrogen will go to this carbon and OH will go to another carbon. So it will be CH2 double bond CH single bond OH. So here there is a change in the reaction. It will undergo rearrangement. This type of question can be easily asked. This is very important just because here a rearrangement reaction is occurring. So the hydrogen will shift to this particular carbon and this double bond will shift to here. So it will be CH3 C double bond O along with H. This is that will form ethanol. So the question can be asked like convert ethine to ethanol. So same method we can easily use. So the conversion can ask by this method. Next, let's talk about the aromatic point of view, that is benzene. Benzene, most important topic. Okay, so how you can prepare the benzene from ethine, or you can say from acetylene, we can prepare this method. So how you'll write the thing that whenever the acetylene molecule undergo reaction or passes through the red hot iron tube, it will undergo aromatization. We have to write like this. Okay, so we have like CH triple bond CH triple bond CH triple bond CH. Okay, this bond will shift this side, this bond will shift this side, and this bond will shift this side. When it undergo a red hot iron tube, when it pass, this is acetylene gas, or you can say ethine. It will undergo aromatization and it will lead to the formation of benzene ring. Okay, or you can make it like this just because the bond is circulating. Second method, from decarboxylation we can easily form. From decarboxylation reaction, like benzene, over it we have COONA, sodium salt of benzoic acid. When it reacts with the NaOH in the presence of CaO, when you heat it, that is again soda lime. NaOH plus CO is soda lime. It will give out Na2CO3 molecule along with the benzene. So this is again most important. Let's talk about the chemical properties of benzene. So benzene undergo electrophilic substitution reaction. So electrophilic substitution reaction start with the halogenation, alkylation, acylation, nitration, sulfonation. We have to do all the important things. So first I'm going through the halogenation. As the name suggests, we are joining the halogen here. So benzene, when react with the Cl2 in the presence of FeCl3. Okay, one of the hydrogen from here will take one Cl and gives out HCl molecule, and remaining Cl will bind over the benzene. It will form chlorobenzene. Chlorobenzene. Second reaction if I'll take, that is nitration. Benzene over H. On every position we have hydrogen on the benzene. Okay, when it react with the HNO3 in the presence of concentrated H2SO4, HNO3 we can write like HOOH or NO2. So just to understand, H will react with the OH. It will give out H2O molecule minus H2O. So remaining is NO2. So it will give out NO2, nitrobenzene. So again, if the conversion is like Convert benzene into nitrobenzene, we can use nitration. Convert benzene into chlorobenzene, you can use halogenation. Third thing, sulfonation. Benzene can react with the H2SO4, H2SO4 in the presence of SO3. It will OH or SO3H. Again, H. This H will take the OH, gives out water molecule remaining SO3H position over the benzene. This is called benzene sulfonic acid. Conversion, benzene to benzene sulfonic acid. Fourth one is alkylation. Benzene when react with the Cl3Cl in the presence of anhydrous AlCl3. X will take on this Cl, gives out HCl. Remaining CH3 will come on the top of the benzene. And benzene along with the CH that is called olivine, or you can say methyl benzene. Now the question can be asked like how can you convert benzene into toluene? How can you convert benzene into methyl benzene? Just the last one that is called acetylation. Alkylation or or you can not acetylation, just say acylation. Benzene and react with CH3COCl in the presence of anhydrous Al. Again, this take the Cl gives out HCl. Remaining COCl will combine at the top of the benzene called acetophenol. Okay, so how can you convert benzene into acetophenol? You can use the reaction acylation. So these are the different topics. You can easily be asked like question paper was the reaction based point of view. The principle of the reaction is also or we can say the reaction method is also. Each method we can use for the Lexange. So first you have to make the graph. So you have to make the standard. First we have to take the cube, use the cube, heat, let it form spinning globule, then organic compound. Then what you have to do, you have to just add, like, you have to heat it till let it form hot. And what you have to do, you have to open it water. You plunge, then the remain this in the just you have to heat it, or you can say you have to boil it, then cool, filter it. The remaining salt less is like chocolate. Uh, so, nitrogen. Let's consider it was but like okay, like we podium. Okay, we have added podium heating it. Okay, podium found has then then the reaction for okay. Now hold molecule. Three molecules. And the again, L N P L L N P L N. Example of the we have so that we are affiliated with react or principle. The with then what is the L expression of right? Yes. We think that very one carbon dioxide, hydrogen, like dehybridization. This is you all and you here at a right. Right, right, right. All tetrahedral in us uh, we have you like a single we have to use a molecule. This small molecule also like in this degree centigrade temperature, height of pH. This heat molecule is like is it yeah, yeah. Here we have double bond pH and yes, then out pH single bond pH and the bond is called organic. So like everybody this like make you uh what already this mark and and mark. Keep this uh side and have already moved the hydrogen that is get a bond and it reacts. We have here we have go to that that will have yes, yes, according to or here it is of, of the art molecule. It is O. Now the hydrogen that that hydrogen second way like yes the yes HBr is of yes 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 of of make more them higher and if of uh, ignorant. But it's like device